Assalamualaikum warahmatullahi wabarakatuh. My name is Salman Radzaini from Bachelor of Science Biology UiTM Police. My supervisor is Sir Muhammad Azhar Zulkifli. Today, I will present to you about my final year project titled Evolution on Antibacterial Properties of Chlorophall Lentifera Extract Against Food Spoilage Bacteria. Okay, my video presentation will contain of introductions, literature review, methodology, result and discussion, conclusions, and recommendations, and reference. Introduction. Okay, for the background of study, the Chlorophall lentifera is a green seaweed species that also known as sea grapes in certain locations. It also has many nutritional value that have beneficial consumption for human in future. The sea lentifera green seaweed are known commercialized culture in open tidal ponds in Vietnam and Philippines. The production costs to grow and culture the sea lentifera are low due to easily and sustainably cultured because of their propagation via fragmentation. It also contains of natural bioactive compound that can act as new antioxidant and antibacterial to fight against food spoilage. Food spoilage is a metabolic process that causes change in texture, taste, smell, and appearance of the food by bacteria. For the proper treatment, the intake of synthetic antibacterial are not good for human health because it can be toxic and exerting a carcinogenic effects. The natural bioactive compound have the potential to substitute the existing synthetic antibacteria. It also can act as a preservative in food industry and also for biodegradable food wrapper technology. In Australia, sea lentilifera are growth commercialization because of the high commercial value, high production rates, and low cost for infrastructure or expertise. The significance of this study is to explore the potential of sea lentilifera potential to become substitute antibacterial to existing synthetic one. This also done to raise the awareness to the world community about the benefit of sea lentilifera bioactive compound. The objective of the study is to extract the bioactive compound from sea lentilifera with absolute methanol and to investigate the antibacterial potential of both extract using this diffusion method. Okay, literature review. The Chlorophall lentilifera contain of bioactive compounds such as phenolic compound, carotenoids, alkaloids, and flavonoids. As shown in this figure, the mechanism of action of phenolic compound antibacterial effects are associated with inactivation of cellular enzymes that change bacterial membrane permeability, which eventually cause cell deaths by increasing the membrane permeability. The methodology. Okay, for the methodology process, there are three main processes which are seaweed extraction preparations, inoculum preparation, and diffusion method. Okay, for the seaweed extraction preparation, 33.753 grams of sea lentilifera had been obtained after drying process using oven for at 50 degrees Celsius for 24 hours. Then the dried green seaweed then soaked in the methanol for 24 hours, and the extraction process had been done by using direct heating using oven. Okay, for the percentage of extraction yield of sea lentilifera are 2.225%. Then, for the inoculum preparations, two bacteria have been used which are gram-negative E. coli and gram-positive B. licheniformis. The inoculum stability was prepared based on McFarlane 015 standard, and the absorbent obtained a 0.0015 at 625 nm checked using a spectrometer. For this diffusion method, there are three concentrations being prepared. Concentration of sea lentilifera extraction have been prepared to test the antibacterial activity, which are 10 mg per ml, 30 mg per ml, and 50 mg per ml. The distribution method are done by triplicate. Result and discussion. For this, the result of this diffusion method has been shown in the table for both bacteria E. coli and B. licheniformis. All of the concentration of Chlorophall lentilifera extract 10 mg per ml, 30 mg per ml, 50 mg per ml, and negative control doesn't show any zone of inhibition. Positive control ampicillin show for 4 mm for E. coli and 6 mm for licheniformis. As for the discussion, okay, all of the three concentration of Chlorophall lentifera which are 10 mg per ml, 30 mg per ml, and 50 mg per ml, failed to inhibit the growth of bacteria when that was introduced on the Mullen agar plate, and no zone of inhibition obtained. Okay, the result of C. lentilifera extracts was contrast with a research paper by Novani in 2018, which reported that the cowpea extract of C. lentilifera show antibacterial activities toward E. coli, S. aureus, and B. subtilis. However, the crude extract of C. lentilifera in the Novani research was evaluated using a rotary rotavat compared to the study that used direct heating using oven. Rotary evaporated extract solvent at high degree of repeatability and efficiency at low temperature throughout the evaporation process that reduced the risk of bumping and flash boiling. While the extraction process using direct heating are prone to oxidation and degradation. For this experiment, we used direct heating process using oven. Then, okay, the biochemical this result also can be effective because the biochemical composition of C. lentilifera bioactive compound could be affected by environmental factors which are seasonal geolocation factors. It also was documented that the biochemical composition of seaweed can be affected by variation in light, salinity, and water temperature. Here, the extract of copper species collected during rainy season exhibit a higher concentration of copper compared to in dry season. The copper lentilifera or lato-lato had been collected in Kuala Muda in the dry season. So this may be the reasons of the fail of antibacterial effects uh, in the experiment. Okay, this similarity of cylinder of metabolic level caused by environmental factor have been challenged faced by sea farming in Australia. Then poor inoculum preparation also can be the reason of this fail. Have been failed because the malfunction practiced during inoculum preparation. Okay, high bacteria inoculum size at the infection site can decrease the activity of antibacterial activity. The high inoculum size also will increase bacteria tolerant to some antibacterial agent because of the self-limiting of bacterial growth. The clinical resistance of the bacteria also can promote the bacterial growth that indicate that the relationships between antibacterial activity in vivo and the cowpea lentilifera extract concentration. Okay, conclusions and recommendations. As a conclusion, this research has failed to prove the ability of cowpea lentilifera to act as a bacterial agent. For recommendation, a minimum inhibitory concentration serialization test should be done for further antibacterial activity test. Okay, the use of blank disk also can be done to substitute the use of paper disc. The paper disc in this experiment as blank disc have more good rate of absorptions. Then for the extraction method, rotary evaporator rotavat can substitute the use of direct heating extraction method using oven. Then the evaluation of Coelenterifera extract from the different seasonal and geolocation can be done to test the different antibacterial potential with different metabolite level and biochemical composition. Okay, these are some of the reference used in my final year project, such as effect of the C of Calvaris mosaic extract and biochemical reaction growth and Imagram by J. Gypsy, and Alsafe antibacterial substance from marine algae isolated from the Darkos Red Sea by Joe A.S. Plant bioactive compound as an intrinsic and sustainable tool to enhance the microbial safe crops. That's all from me, Shazani Salman. Thank you.